So, we have three metal blocks marked A, B, and C. Block A is positively charged, but blocks B and C are neutral. Without using any additional equipment and without altering the amount of charge on block A, explain how you can make block B positively charged and block C negatively charged. Well, first, we're going to ask ourselves, what effect does the positively charged block have on the other two blocks? As block A is charged, block A will create an electric field, and because its charge is positive, we know that the electric field it's creating is pointing away from it in all directions. Although for our purposes, we can disregard everything besides its effect on the blocks to the right. So, what is the effect of the electric field on blocks B and C? It polarizes them. That means that, due to the electric field acting on the blocks B and C from the positively charged block A, electrons in blocks B and C are attracted to the left, and an equivalent amount of the positive nuclei are repulsed to the right. So now, how do we charge blocks B and C? Well, keeping in mind the polarizing effect block A has on blocks B and C, and remembering that charge diffuses across conductors, we realize that if we push them together, the positive charges will be repulsed onto block C, while the negatives are attracted through to the left-hand side of block B. Now we just need to configure it so that the electrons are collecting on block C instead of block B, and the nuclei are collecting on block B instead of C. So all we need to do is switch the placement of B and C. And then, with all the charges on the right blocks, we just need to separate the blocks. Note that if we removed block A, and consequently its electrical field, before we separated the two blocks, block B and C would become neutral again because charges distribute evenly over the surface area of conductors.